To the next lesson on molar concentration. In this lesson, we're going to be looking at the importance of solvent properties in biological conditions and domestic conditions in industrial contexts. So, concentration as a molar concentration. What does that mean? Well, the concentration in moles per litre, which is also written as moles per litre minus 1, allows us to compare the amount of moles of two different solutions, and we're looking specifically for the atoms, molecules, or ions in a given volume of solution. So for example, if we have a 0.1 mole per litre amount of hydrochloric acid, there'd be 0.1 moles of hydrochloric acid in 1 litre. So the concentration in moles per litre can be calculated by using the following formula. And we can see here, we have the amount of solute in mole, so you need to calculate the moles first, and then you divide that by the volume in litres. That can also be represented by concentration equals N over V. So it can be shown in a formula triangle as such. Moles up here, concentration in molarity, which is moles per litre, and then volume in litres. Shown here in the formula triangle, you can see there are many ways of writing or recording molar concentration. We can talk about something having a concentration of 1 mole per litre. We can say it's got 1 mole per litre minus 1, it's 1 molar, it's 1 m, or has a molarity of m. You don't have to know all of these, you just need to be aware to be able to use one of them as reporting your units for concentration. So if you, for example, had a molar amount, you divide it by its volume in litres, you give you concentration, and you report that in one of these certain units. If there was 1 molar, and if there's obviously a different number of moles, then you obviously need to change this number in front there. So let's do an example. Calculate the concentration of a solution that has 0.105 mole of potassium nitrate dissolved in 200 ml of solution. So to simply do this, we want to calculate the concentration, the molar concentration, which is this number here, this coefficient. To do so, following the formula triangle, anything that goes from the top down to the bottom, we divide. Anything that goes from the left to right or right to left, we multiply. So we want to find concentration. We have the moles here and we have the volume here. We simply divide the two. Before that, we need to convert the volume into litres. So you've got your volume, 200 mils, divided by 1,000, which will convert it from millilitres to litres. We have 0.2 litres. Now the concentration is simply dividing the moles over here by the volume, which is over here, moles here, volume there, which gives you 0.525 mole per litre minus 1, or 0.525 m, capital M. This is another flowchart workings here. We can see that it's slightly more involved what's required to calculate the concentration in moles per litre of a particular solution. That's because we've been given a mass in grams, and we need to use the second form of the triangle, which is shown here. So the first thing you need to do is we always convert our units into the appropriate context or appropriate units. So we have 150 mils there. That needs to be in litres. If we're going to be working out the concentration, we need to have it the volume in litres. So we convert 150 mils into 0.15 litres by dividing by 1,000. Then we convert the mass, which here's our mass, that must be in grams. So we're using this formula triangle. We know that our mass divided by our mole mass there is equal to our moles. Before we can divide our mass, we need to convert it into grams. Now we calculate the molar mass of silver nitrate, and we divide the mass by the molar mass, which gives you the amount in moles of silver nitrate in that particular sample. From there, we finish with this equation here. We divide the moles by its volume, which is 0.15 litres, and we have the final form of the answer, which is 0.000659 moles per litre, or 6.59 by 10 to the negative 4 moles per litre. This is just a third example here where we're actually multiplying and we're using the formula to calculate the volume, the amount in moles. So we've got the concentration, we have the volume, we want to work out the moles. To do so, you simply multiply the volume by the concentration, but you need to first convert the volume into litres, which is done by dividing by 1,000. And you can see 0.3277, the moles by the volume there, gives you this number in moles. This is what you need to know, or a summary of the lesson. Concentration is a measure of how many particles there are in a solution, and it's measured in moles per litre minus 1, which is also represented by capital M, known as molarity. Concentration is calculated by the formula C equals N on V, and this is what you should be able to do the lesson now. Use this formula to calculate concentration, and use the formula, this one here, and this one here, to calculate concentration from a given mass. These are the questions I'd like you to complete. Thanks for watching.